Today we're going to be working on Chapter 6.1, the parabola. After you listen to, this will probably be at least 2 recordings to get through the parabola section, you'll be working on homework. If you have mathexcelforschool.com, simply complete the 6.1 homework. If you have a textbook, it starts on page 532 and are the problems listed here. What we're going to be working on between now and before we start our final exam review is several of the conic sections. Today we'll be talking about the parabola. The next class we'll be working about the circle and the ellipse. And finally, we'll be working with the hyperbola. And by the time we get finished, you'll be able to do all these things listed on this page. But what are conics or conic sections? An ancient Greek was messing around with trying to square the triangle, cube the circle, do a variety of different things. And what he discovered is when he stacked two circular cones, these are right circular cones, and this is called right nap cones, but they're stacked, as you see here. And when he cut them with planes, a variety of different ways, he came up with a parabola if it's cut on a slant. Another way of slanting it, you get an ellipse if you cut it with this purple plane. If you put it through at a right angle, you do get a circle. And you can see if you cut through both of the cones together, you get a split graph, which is a hyperbola. And then each one of these different shapes can be derived from this long equation here. The good news is we're not going to make you do a lot of, or actually derive the equations from this equation, but you will be completing the square occasionally to get the correct equation. But today let's start with just our parabola. The definition of a parabola is a parabola is the set of all points in a plane that are equidistant, which means the same distance, from a fixed line, which is our directrix, and a fixed point down on the line called the focus. We've learned in the past that all of our parabola, or this quadratic equation, will graph a parabola. The equations we're going to be using today are a little bit different. Please note that this focus is right on our axis of symmetry, which is that imaginary line that cuts our parabola into two equal halves. The equation we're going to be using for our parabola in this section, with a vertex at 0, 0, and our directrix at y equals negative p, is x squared equals 4py. I know it's a little different than what we see here, this, which is the ax squared plus bx plus c, but this equation can be derived from that equation using our distance formula. I'm not going to derive it for you. I'm just going to show you how to use this particular equation to find our focus, find our directrix, and to graph parabola. Please notice that the focus is our point 0, p. And that is this point right here. Here's our focus in this case. And our directrix is y equals negative p. It is the equation of a line. Now, if this were upside down parabola, our focus and directrix would be flipped. A parabola that's on its side. Now we're going to work with these. Before in Algebra 2, we worked with parabolas that opened up or opened down. Now we're going to work with parabolas that also open left to right, or left or right. Please notice that the vertex is still 0, 0, But what has changed in our equation is that it's now y squared equals 4px, and my directrix is x equals negative p. If it's flipped the other direction, note that this is going to be y squared equals negative 4px, and my directrix will be x equals p. The focus is our point P0, and the x-axis is the axis of symmetry, so it would be right along our x-axis. Let's see how this works in an actual equation. Sorry about that, I'm not sure what happened. Here we're going to find the focus, the directrix of the following parabola, and then we're going to graph the parabola. I've listed the steps here, and I will explain them as I go through. When we're given an equation, x squared equals 8y, our first step, since x squared is already isolated, is we're going to find the focus by setting the coefficient of y, which is 8, equal to 4p. Then we're going to solve for p. P, if we recall, is our focus. It is actually the y-coordinate of the focus. So I said 8 is equal to 4p, divide both sides by 4, and I get 2 is equal to p. I then write my focus as 0, 2, and I can actually plot that focus now. Make sure it's red on a nice big point here. And I said it was at 0, 2, so I plot it right here on my x-axis at 0, 2. And then I'm actually going to draw my directrix, which I know is y equals negative 2 because it's actually just the opposite of p. Y equals negative p. My focus is 0p. I now have two things plotted on my graph, but I need to know where to draw my parabola. I can't just make a random U shape. I do need some points to put in. So I'm going to make an XY chart and graph the parabola. I will need at least 5 points to graph this parabola. And that is the vertex, which I know is 0, 0, and 2 points on each side of the vertex. You can use your graphing calculator for this, but you need to convert the equation to y equals 1/8 x squared. What I did is I put in, why is that 1/8? Oh, what I did is I had to solve for y and divide both sides by 8. Instead, I didn't do that actually. I just used fractions, which I know you guys hate. So you would actually probably have put in -1 and get 0.125 for y. Put in -2 is equal to 1/2. Or simply use fractions by putting some points in for x and solving for y. I now have some points to graph, so let's graph these. I'll use purple. And I have 0, 0, which I'm plotting. I think I'll make these nice and big. So I have 0, 0. At -1, I'm only going up a tiny little bit to 1/8. -2, same thing, a tiny little bit. I'm going to try to connect these with a smooth, continuous curve. If you want to know if this is the exact parabola that you're looking for, you could always plot a few more points. And that's all there is to graphing it. Let's try another one. Here we need to find the focus, the directrix, the parabola, and graph it. This is 3y squared equals 12x. Step 1 is to isolate the y squared. So I'm going to divide both sides by 3 to get y squared by itself. Then I'm going to find the focus by setting the coefficient of x equal to 4p and solve for p. This is going to be the x-coordinate of the focus because if you notice, this is in the form of y squared equals 4px, which means it's going to be a parabola that's going to be on its side. So it's going to be one that opens to the right, something like that. So what I do is I'm going to find my focus. I isolate my y squared, get y squared equals 4x. I take my coefficient of x, which is 4, set it equal to 4p. Oops, I'm missing a 4 there. Divide both sides by 4, and I get 1 equals p. Thus, my focus now, which is 1p, is actually, it's not 1p, it's 1, 0. And my directrix, which is x equals negative p, is x equals negative 1. So let's go ahead and graph the focus and draw the directrix. Nice big fat point. Here's my focus at 1, 0, and my directrix is the line x equals negative 1. So it's simply a straight line here. When you're graphing these, you do need to show me the focus and the directrix. Next, make an xy chart to graph the parabola. You need at least 5 points to graph the parabola, the vertex, and 2 points on the side of the vertex. These are the points I chose. I actually put points in for y, not in for x, since I had to find the square root. And these are the points I came up with. Go ahead and check by putting this in your calculator as y equals the square root of 4x, and see if you can come up with these points also. Remember, it's plus or minus. So I'm going to plus, when I mean plus or minus, it's y, but y equals plus or minus the square root of 4x, and y equals minus the square root of 4x. I'm going to plot these points, and then draw my parabola. So I have 0, 0, 1, negative 2, 4, negative 4, and the same as on this side. And connect it with a smooth continuous curve. Okay, this ends this video, and I'm going to start with the next video to continue with the lesson.